Welcome, my name is Sarah. I'm going to be your facilitator for this evening's webinar, and I work here at DairyNZ, and I have the pleasure of introducing you to some of New Zealand's greatest minds, scientific minds from actually across the world. We've got quite the multicultural group here this evening. So in the interest of time, we're going to just crack right on. I will say that we have so much good content, we're probably going to run 5 minutes over. So I'll warn you now, we wanted to make sure there was plenty of discussion because that's part of what was advertised for this evening's event. So wanted to make sure that you guys got plenty of that. Just get my slides going here and share that with you. So this is Science in Action with our DairyNZ scientists and collaborators. And the format for this evening is Jenny is one of our principal scientists, is going to give you an overview of dairy and science and research that we're doing at the moment. And then we're going to have 6 short presentations, and we're going to split that up with a discussion, as well as I'll launch a poll or 2 as we go along to get your feedback and input. And like I said, we might run 5 minutes long. If you've got to carry on, it's okay. We're recording tonight's session, and you'll be able to find that on the Farmers Forum webpage on DairyNZ. So with no further ado, I'm going to turn it over to Jenny Jago, our principal scientist, and she's just based in Hamilton. So Jenny, I'll pass it over to you.
Thank you, Sarah, and good evening, everyone. Thanks for joining. One of the really great things about dairy farming in New Zealand that I think is the willingness of farmers to turn to science to help make progress in your farming systems. It's a pretty complex and dynamic world out there, and on this slide you can see how we break down into the 3 big outcomes that we are supporting farmers to achieve, and the big areas for our science to focus on. So firstly, to be globally competitive, we really need to stay connected to our customers, and almost all of those are offshore. And we need to think about what they want from their food and how it's produced. Outside of food safety, the big areas that are of interest there are in carbon footprint, greenhouse gas emissions, and animal well-being. If we come across to at home in New Zealand, we need to think about the responsibility we have as large landowners and major contributors to the economy, and how we support New Zealand to achieve its goals. And it's really no surprise there that water quality is the big focus at the moment. And it's important to understand that while New Zealanders are not our major customers, they do have a lot of say when it comes to our licence to operate. In our regions where we farm, we have to think about the specific challenges, which may be access to staff or the ability to grow a reliable feed source or feed base. And above all, when we think about those 3 big areas, we are very highly aware of the need for businesses to be profitable while considering the expectations of modern workplaces and modern businesses. So there's a lot going on. The goal of DairyNZ Science is to help provide you with options for these challenges. And we don't work alone. We put a lot of effort into finding the best teams, which means investing in and working with other science organisations, maybe in New Zealand or overseas, to make sure that we've got access to the latest knowledge and the latest thinking. We put a big emphasis on making sure the options are ones that will truly work. So testing in farm systems is also a big part of what we do. We aim to work closely with you as farmers and others that will use the work, and that increases the chance of the work being, or of us solving the real problems, and also helps speed up the adoption of the new knowledge. So this evening we've got a selection of our team to talk about the work that they are doing at the moment. And some of that work is in the early stages. Some are up to testing the components in a research setting, and others are really grappling with making the technology work at scale on farms in a catchment. So I really do hope you enjoy the session and encourage you to use the chat function and the question and answers. And we'll do our best to answer those questions. If we can't answer them tonight, we will endeavour to do that after and put them on the Farmers Forum webpage. And that's it from me. Back to you, Sarah.
Okay, so as Jenny said, we've had a few more people join as well. If you've got questions, pop them in the Q&A or the chat. Those are both along the bottom of your screen if you've never been in a Zoom meeting before. We're going to take some of those questions through to the discussions that happen after 3 presentations and answer some of those questions. And like Jenny said, if we can't answer them all here or we don't have time for it, the answers will be provided later on the website. So that's your way to engage, is to pop your questions in the chat and the Q&A. So first up, we've got Elena Minnee, and she's going to talk about reducing methane, but I'm just keen to get your feedback on what you guys think about methane inhibitors. So I've got this, I've got a poll that I'm just interested, would you consider using an inhibitor compound to reduce methane emissions on your farm? So if you just have a wee click to select which one of those best represents you, yes, no, or unsure. We'll give it a few seconds. About half of our participants have voted so far. We've got a few more answers coming in. 5, 4, 3, 2, 1. I'll close off polling there. So just as I hand over to Elena, 50% of those that answered said yes, they would. We've got that 18% that said no, and we've got a third of our audience that is unsure. So perhaps you'll have something to share with us that may influence our views on reducing methane inhibitors. So Elena, if you just want to pop your camera on so they can see your lovely face. And what work are we doing in reducing methane with inhibitors?
Thanks, Sarah. Can you see and hear me now?
Yes, I can. Thank you.
Thanks for that poll. It was really interesting. It's interesting that we're clearly on the right track looking into this, but we've got some work to do to help people with their uncertainty and understand why people aren't interested in this technology, which is valid. So I know you are all very, very well aware of the government's activities around setting in place targets to reduce greenhouse gas emissions, and that for dairy, the big one is methane. And there's, lots of discussion around whether we have the technologies in place already to meet that early 2030 target, and perhaps even the minimum target proposed for 2050. But it's generally pretty well accepted that in order for us to meet that larger proposed target that we could have in place by 2050 of 47% less emissions of methane, we're going to need some really significant technologies in order to help us achieve that without losing production. And one of these technologies could be methane inhibitors. Next slide, please. So methane inhibitors, they're essentially compounds or chemicals that when given to the dairy cow or any other ruminant, they directly stop the methanogenic bacteria from producing methane, either by directly targeting those bugs or upsetting the metabolism of those bugs that they use to make methane. So the overall result is just less methane that the cow produces. Next slide, please, Sarah. And I'm also certain that you've probably heard quite a bit about methane inhibitors in the press. They could be natural products like seaweed, that's most commonly been talking about recently, or tannins, or even, dare I say, things like lemongrass or essential oils, or they could be synthetically manufactured. And the reports that we're seeing from some published studies are suggesting that there could be a 30 to 90% reduction in methane emissions from livestock when they're fed or treated with methane inhibitors. Even yesterday, there was a report from the beef industry in Australia of a 90% reduction in methane emissions from beef animals with no effect on productivity. So that's a huge reduction that could get us a really long way to achieving that technology or achieving those targets. And it could do that fast. But there is a catch, like there is with everything. Next one, please, Sarah. That's the catch. The reason they work so well in those feedlot systems overseas is that to be most effective in mature ruminants, the methane inhibitors need to be present in the rumen all the time, acting on those bugs. So that's super simple in those feedlot systems where you can mix that compound into the feed and the animal's continuously ingesting that compound and it's working its magic. But adding it to a grazing system is much, much harder. You can't simply spread these compounds across your pasture like you would minerals, for example. So we're setting up other projects to see how we could actually deliver this compound to animals in our grazing-based systems, whether that be through technologies, in-shed feeders or automated feeders and things like that. There are a group of people also working on slow-release capsules, but the rub there is that you really need to find an inhibitor that's potent and long-lasting enough that it can be in the rumen without being the size of a small rocket. So there are people working on that, but it's not as easy as we would like it to be. So next slide, please. So as well as the question of how we're actually going to integrate these compounds into our grass-based system, there's a raft of other things that we need to consider before we start rolling these things out onto farms. We need to know if they're safe. Is there any risk of residues in our product? Is it going to affect the nutritional value of our milk? And what's it going to cost? So there's a lot of really big questions that need to be answered, but the potential of these compounds does suggest that we do need to be engaging in this research and seeing if we can implement it into our systems here. So we're partnering with other research organisations and with technology developers to basically see if we can evaluate the lead components or the lead compounds that are showing promise. Because let's face it, this could be an area where the market could have a lot of snake oil type products, but we are engaging in projects where our role will be to evaluate those lead and most promising compounds to find those solutions that can work in our systems and be effective. Thank you very much.
All right, thanks for that, Elena. Next up, we've got genomic breeding in forages. So this is Marty Faville, a plant geneticist and team leader from AgResearch. So Marty, what's happening in the world of genomic breeding?
Oh, heaps, thanks, Sarah. Yeah, so I'm Marty, I'm from AgResearch, not DairyNZ. I'm going to talk to you about a component of a program that we completed recently called Pastoral Genomics, in which DairyNZ was one of the two major investors. So I'm talking about genomic selection, and many of you may have heard of this. This is a genomic-driven breeding strategy that's designed to lift the rate of genetic gain or improve genetic progress through breeding. And as you'll be aware, it's used routinely in livestock, including dairy cattle. So what it is that we're using DNA information in the form of markers to predict the breeding value or trait values of individuals, instead of actually having to do the trait measurement itself. So in ryegrass, for example, if we want to measure herbage yield, we typically have to evaluate plants in the field for 3 years. In genomic selection, potentially what we can do is grow a seedling for 6 weeks, extract DNA from it and plug it into a genomic selection model that then spits out a breeding value straight away. So genomic selection can help us to improve that rate of gain by speeding things up, so we can do many more breeding cycles per unit time. And in some ways, we can use it to improve accuracy and get greater gain from each breeding cycle that we complete. And I just want to point out, this has really only been enabled in forages through the advent of new genotyping technologies, including genotyping by sequencing. And that's something we can potentially apply to just about any forage species. But I'm going to talk about perennial ryegrass and white clover. So if we just go to the next slide. So this is a summary on this slide of what we managed in 5 years. So we showed the potential for genomic selection by being able to develop genomic selection models for more than 20 traits across the 2 species. And they're listed in the table there. So for ryegrass, just noting that we have models for herbage yield, nutritive quality, and persistence traits, which of course are all elements of the dairy forage value index. Apart from, or moving on from just developing those models, we wanted to actually test some of them by doing some breeding with them at a research scale. So there's an example of that shown in this figure here on the right of the slide, where we used genomic selection to select individuals. We crossed them together to generate seed or progeny, and then we evaluated those progenies in field trials. And this is about halfway through the trial. We can see on the left-hand side, the base population or the source population has had nothing done to it. In the middle, next to that in the dark blue, is where we applied just a conventional breeding approach, and we were able to improve things by over 20%. And then the green bar on the right-hand side is when we integrated genomic selection into the system, and we were able to nearly double the selection response. So if we go to the next slide, genomic selection has great potential for us to really ramp things up in the forage world. In terms of benefits to you, the farmer, they're probably a wee way away, but the boxes on the left-hand side show the current situation. So the rate of gain for herbage yield and ryegrass is currently at best about 0.7% per year. The modelling and the data that we've generated suggests we can improve that to 2%. And Abacus Bio took those numbers and did some further modelling, and they suggest that if the current value of pasture to dairy today is about $14 billion per annum, if we were to implement genomic selection across the industry by 2026, then in 2040 we could be looking at an additional 0.4 to 1.3 billion per annum. So hopefully there's an animation just on its way. You might need to click it, Sarah.
All right.
There we go. So we're working on getting a new program funded where we aim to actually realise these benefits. So getting from the research scale to the implementation scale and having genomic selection working across the seed industry. And we're also going to turn this technology towards some priority traits in the areas of environmental footprint and climate resilience. So things like improving the plant's ability to make use of nitrogen, so less nitrogen needs to be applied, and looking for drought tolerance or heat tolerance as well. So that's me. Thank you.
All right. Thanks so much for that, Marty. It's amazing to see 14 billion could come from genomic selection. So you're in the big bucks industry. It's great to see that we've got questions coming in the chat and the Q&A, and we're going to get to those once we talk about regenerative farming. So Bruce Thorrold is our strategy and investment leader, and his background is in research science from Fada. So Bruce, what's happening in regenerative farming?
It's all go in regen farming, Sarah, particularly the debate, which isn't always helpful. So what I want to do tonight is just share a bit of thinking and provoke a bit of discussion. So what is regen ag? I mean, I've got it down as being 3 things, and they're 3 quite different things. The first thing it's a philosophy of farming better and continuous improvement. And people get wound up because they can't define regen ag. Well, here's a pretty good definition of regen ag. It's any practice that makes the land, the community, and the bottom line healthier year after year. And that's a pretty good definition. I've seen people get really tangled up in this and get to the idea that you can't be regenerative unless you've wrecked the place to start off with, and that's really unhelpful. Regen ag comes out of degraded grasslands in Africa and cropland in the US where soils and pastures have been run down, and so they've looked at things like soil carbon and gone, well, we've wrecked the place, we've got to make it better. In the New Zealand context, soil carbon, which is a key regen thing, is already very high. Our systems produce big inputs and maintain soil carbon. So we don't need to start by assuming we've wrecked the place to see value in getting better. And if you look at Dairy Tomorrow, which is our sector strategy, it's entirely consistent with a regenerative approach to making things better all the time. Next slide. And it's two other things. It's a social movement. This is not really based in science. It's more based on how people feel about things. So it's a social movement of farmers and consumers who want to be connected and be part of better farming and better food. Of course, all movements like this get joined by consultants, NGOs and salespeople who have their own agendas, and sometimes that muddies the water as well.
Do you mind just clarifying what's an NGO, Bruce?
A non-government, Greenpeace.
Oh, right, okay.
Greenpeace believes that for its own reasons, of course, that this is the future. And the third thing it's an uncontrolled and loosely defined set of practices with pretty mixed scientific support. I'll show you a slide in a minute, which will show you that many of these things are well-proven standard practice in New Zealand, and some aren't. And it's very different from the highly prescribed organic systems, which have some similar philosophies. And farmers like this because being able to pick and choose what's working at the time is very attractive. It's not as easy to be better every year as country calendar makes it look. Next slide. So here in Regen farmers' own words are their practices, and I've kind of grouped them as proven to work. As promised, this is what they do, what it says on the tin. Proven not to work and worth debate. So if you look across the top row, you'll see that grazing practices are a really central part of regen thinking, and really well aligned mostly with what we do here in standard practice. So intensive grazing, wintering with with bales, putting grass out there for cows to eat, standard practice. Regen tends to feature low feed utilisation, and we know that doesn't work if we're focusing on production and profit. It also features long rotations and high residuals, which have some unknowns in them around greenhouse gases, particularly carbon and nitrogen cycling. So there's areas of research which are worth doing in a different context. Diverse pastures and crops are key. Over in Regen, very high diversity, sowing 16 to 14 species is kind of standard practice. And down in the bottom row, reducing fertilizer and chemical inputs, looking for efficiency, standard practice and well proven to work in our research in terms of driving nitrogen and methane emissions down through de-intensification. We know that other practices using humates and seaweed extracts and other natural products which regen farmers, some of them, and practitioners claim will buffer or substitute for fertilizer doesn't work. So a mix of things that work and don't. Sarah, please. So to summarise, is Regen Ag the future? Well, as a philosophy, I think so. I mean, Dairy Tomorrow is all about being better. We might rename it. MPI is running a program called Tatio, which looks to kind of bring New Zealand Inc. together under one banner. As a social movement and a mindset, probably, and potentially a connector between farmers and our consumers and neighbours. We need and we want to feel better about how we farm and to be supported in what we do. As standard practices for farmers in New Zealand, while some are already standard practice, some certainly shouldn't be, and some need more research.
All right. So that brings us to the end of our first 3 snapshots. So Marty and Elena are going to join us again in our panel discussion, and we've just got 5 to 10 minutes here to answer some questions. So the first question that had come in, Elena, was what are maybe some other options other than for low input farmers to get those methane inhibitors into the diet?
That's a good question, and I guess that's why there is a team that's working on these slow release capsules, or there might eventually be some sort of dosing or drenching. And there was a really good question in the chat too about using inhibitors early in life, so that there's a few programs of work that are looking at applying the inhibitors when your calves are weaning in the milk or the meal. So we're looking at that work because there is some that is suggesting that you can change the the makeup of the rumen community early in life that has a persistent effect for at least 12 months. So we're looking to see whether we could make a low methane animal from the early life application of methane inhibitors.
So what Elena was referring to there was a question in the chat saying, you know, are calves born with these methanogens in their rumen, or do they pick them up somewhere along the way? And so Elena's response is just to that there. Just on that methane inhibitors, is it possible that if we had animals that produce less methane, we could actually gain better production, so that energy that's going into methane could actually go into production?
Yeah, that's the theory, and it works really well in the lab, but it's it doesn't always translate at the cow level. There has been some research overseas to suggest that there has been improved production from these animals that are having significant reductions in methane, and they are producing more, but these are mostly with beef animals. We haven't seen that yet in any of the dairy studies, but then there is limited studies at the moment. We're still very, very early days. So the theory is there, and we just need some more testing to see if it would be realized.
All right, I've got two genetics questions here. The good news is, Marty, one of them is about grass, but our first one is about animals. So can low methane production be influenced through breeding? So can we find genomic markers for low methane animals? Do they exist? We don't know. Who wants to answer that question?
I'll have a go.
Okay.
So PTGRC, we've found that we can breed for low emitting sheep. Reasonably confident we'll find low emitting cattle. That's currently a study that's being run now with LIC and CRV and Your Money through the levy organisations. So we will see. History shows that if we can find a physical measure, you know, a phenotype and select for that, then we can use genomics to speed that process up in animals and in grasses.
All right, now we've got our grass questions. So Marty, where does GE fit into improving the rate of progress, and how acceptable is this to the market?
Well, the second part of that question is that the market needs to tell us that. Look, I don't work particularly in that area. That's work that my colleagues are involved in with high metabolizable energy ryegrass. My comment would be that GE offers a way of creating step change improvements in traits such as nutritive value, potentially productivity, whereas what we're doing in terms of genomic selection is around improving the rate of incremental gain. So if there is market acceptance, if there is farmer acceptance, if there is societal acceptance of GE, then certainly it has a big role to play in improving a whole range of traits, actually.
Okay. And then Stuart's asked, is methane production related to digestion? And if digestion is improved, does methane production reduce?
Yes, methane is very much related to digestion. So when your feed is digested, you know, you produce sugars and such that the animal uses, and hydrogen is produced, and that hydrogen has to be removed. If it accumulates in the rumen, you'll end up with a reduction in digestion because that sort of upsets the other bugs in there. So it's that. So the methanogens are doing a job getting rid of that hydrogen for the animal, but when they are not, when they are suppressed, then that hydrogen can be sort of diverted into other metabolic pathways, like, you know, producing another sugar that can be used. So, so it is a bit of it's a fine balance, and now I've almost forgotten what the question was. So the two are different.
Oh, so if you improve digestion, can you reduce methane production?
Good. If you improve digestion, generally the more an animal is busy fermenting away, the more methane she'll produce. But then it gets into, she'll also possibly be producing more product. So she's probably
She may be more efficient.
Yeah, her methane intensity might be improved. So the gains that you guys have been making in feed efficiency have also made us more methane efficient. It's just the total number, the total emissions per day has also increased, and that's the number that we need to get down at the end of the day.
Okay. Bruce, we've had our first regen question come in. So here we go. If regen is mainly New Zealand farming already, why is it getting so much oxygen as an idea?
Because it's a social movement, Phil, because people really like the idea. People from the Prime Minister down really like the idea that if we just farm better, all these problems would go away. Quite honestly, at DairyNZ, we've been trying to limit the amount of oxygen it got because we see there are risks to people picking up this idea and just running with when we know there are some fish hooks in the practices. So we're trying to keep the debate very much on the science and the practices, but how do you make the most of what is a potential, a social movement of potential value to us.
All right, well, it looks like we have used up all of our questions. So thanks so much to Bruce, Elena, and Marty. Yes?
If we haven't used up our time, can I just add? We
haven't used up our time, no.
So just to add to Marty's answer about GE. So DairyNZ is investing alongside others with the GM forages, the high lipid grasses that AgResearch has developed. The potential of those 4 years ago was high yield and higher lipid content, which drives animal performance and lower methane, which is a real potential winner. What we're seeing in trials offshore, because we can't use them here at the moment in the field, is that we're getting those lipid gains. We're not seeing anything significant in terms of dry matter gains. So there's potential there to take, as Marty said, to take ryegrass to a place in terms of its lipid content and its methane generation that you couldn't breed to. So that's the upside.
So while we were talking about that, we've just had a question here from Jeanette that we've got plenty of time to answer. So is there a difference in the amount of methane that's expelled depending on the forage eaten? So does forage type influence methane production?
Yeah, good question. It's one of my favourite topics. We are still finding exactly what traits about forages might influence methane production. The biggest driver is the amount an animal eats will essentially dictate how much methane she produces. So that is the strongest correlation, but there are certain forages that do reduce methane emissions, things like forage rape or fodder beet, things that have a lot of sort of fermentable sugars, things that might be high in nitrates, which actually suppress the methanogens, but then that might cause another problem. So there are certain traits about forage and certain forages that are low methane forages. So there is a program of work that the Pastoral Greenhouse Gas Research Centre runs looking for low methane forage, and DairyNZ invests in that, and we're doing some work at the moment on assessing the emissions from Plantain, because we're looking at that obviously as a nitrogen leaching mechanism, and you'll hear more about that later, but we also want to make sure we're not creating a different problem by having something that might increase emissions. And some of the early studies are suggesting that the emissions might be similar, or they could even be reduced, so when you feed plantain as part of the diet. So it is certainly an area we're looking to improve our understanding of, to look for these species that we can use.
Okay, well, thank you to Bruce, Elena, and Marty. I'm going to stop us there so that we can move to our next three panelists. We've had a couple more questions come in, so if we get time, we might loop back to you guys with more regen or forages or methane questions. But we are moving on to dairy calf opportunities. So this is another piece of work with Ina Pinxterhuis, and Ina just wanted to get some feedback from you guys on what you were doing with the live calves that are born on your farm. So I'm just launching a poll now. What percentage of the calves born on your farm do you sell for beef or you rear for beef on your farm. So this is excluding your heifer replacements. What percentage of those that are born alive do you rear for beef or sell for beef? About a third of you guys have given me answers. I'll give it just a few more seconds. 5, 4, 3, 2, 1. All right, we'll end it there and share the results. So about a 20 to 30% or 30% of people, our highest group there are 20 to 30% of the animals. 18% or 3 of our audience members, more than 40% of your animals you're using for beef, but about a quarter is doing very, very little for beef there. So Ina, I'm going to stop sharing the poll here and let's get into the work that you're doing with calf opportunities.
Nice. Thank you very much, Sarah. And thank you everybody for filling in that poll. And I thought the result was really interesting because it totally reflects the results of a survey that we've done amongst you dairy farmers end of last year. A total of 262 farmers responded and we were interviewed, and that was from north to south and all sorts of different farm types. So a really nice overview of the dairy sector, I think. And the average of these farmers, the average number of calves born alive that were sold for beef rearing or reared for beef on the dairy farm itself was 27. So that was exactly where your majority also voted for. But also here in our survey, we saw a huge difference from farms who would rear all of them or none. So a really big spread. So from, sorry, Sarah,
Oh, sorry.
I wasn't finished with that one. So 28% of the calves born alive are reared as replacement stock. So it's a very familiar percentage, I think. And 35% are processed as bobby calves. But in the survey, 60% of the farmers agreed that we as a dairy sector should aim to decrease that percentage and look for opportunities for our bobby calves for more productive use. And that does have some additional than just for the bobby calves and being more productive. It might also have a benefit for our environmental footprint. Some colleagues from AgResearch published some more work last year and early this year that if we were producing more beef from dairy calves instead of having beef animals, we could significantly reduce the overall greenhouse gas emission. So can you now go to the next?
Oh yes,
Sarah, thank you.
Yes, yes.
We also looked overseas, of course, what others are doing, our competitors overseas. And we see that in Great Britain, they already have a dairy calf strategy in place with the aim of having 95% of the non-replacements going to beef production by 2023, so in 2 years' time already. Arla UK has been quicker. Per the 1st of January this year, all their suppliers need to rear or have somebody rear their healthy calves till at least 8 weeks old. And their assumption is that if 8 weeks is invested in these animals, that they will be reared for beef production. Ireland is another important competitor for us on the world market, and they are in a very different position. They do not have any bobby calf processing in the country because they transport them to countries like the Netherlands or France for veal production. But both veal production and the long-range transport is under discussion in the EU from animal welfare point of view and public perception as well. And the way the debate is going, people expect that the long-range transport will be ruled out in a few years' time. So seeing all this happening, the Dairy Tomorrow, or Dairy Tomorrow strategy steering group has made this objective of more productive use of our bobby calves as one of their collective work priorities. It is not a topic that the dairy sector can do alone. So we are working sectoral to look at cooperation and developing a program of work. So if you go to the next slide, Sarah, thank you. This summarizes the ideas that we have to date for a new program of work. Some barriers that farmers mentioned during the survey are given here. These are the most important ones. And up top is really that uncertain value. So you put costs into dairy calf rearing for beef production, but there is an uncertain value of these animals, and also for calf rearers and beef finishers. And then if you do use beef bulls on the dairy cows, calving difficulties is certainly a problem. So we want to tackle both of these, first of all, by understanding better the consumer views of our milk and meat products, and looking at opportunities for new beef products like a rosé veal or a young beef for new beef markets. If that is a goer, or even if just there is more space for the normal beef market, we do need to make sure that we do produce quality dairy beef animals. So that is looking at the genetics, suitable sires for dairy cows. Some initial work has been done already by LIC and Messi and Salmon, for example, looking at sires. So some are available, but if we need to scale this up, quite a bit more work needs to be done. And if there are more animals coming through, and even if they're a different type, a young veal or a young beef animal, the infrastructure, and especially at the processing plants, needs to be adjusted as well. So we're working across that sector too, of course. And another thing is around that uncertain value and the risk across the supply chain is to look at sharing risk across the whole supply and value chain. So all in all, with all these quite major questions to address, we hope that we will come with some more options together for productive use for our bobby calves, and hopefully also then have new scenarios that we might reduce our environmental footprint across the whole dairy and beef sector. Thank you, Sarah.
All right, thanks, Ina. We've had a couple questions come in for you, but you're going to have to wait to answer them, because next we've got Jane Kay, our senior scientist, talking about the regional research happening around the country. So what's happening in the big wide world, Jane?
Thank you, Sarah, and great to have so many farmers along tonight. So we've already heard of some of the key challenges that all New Zealand farmers are facing at the moment: methane, bobby calves. But what we know is that New Zealand is a unique country. We have different regions that endure different climates. We have different regions with very different landscapes and ecosystems. And we have farmers within the different regions that are faced with different restraints, different regulations that they have to deal with. So in order to address this diversity, DairyNZ is involved in many projects throughout the regions. And Sarah, if you jump to the next slide, we will see what some of these are. So these projects are diverse in themselves. They some of them involve measuring and monitoring pastures, crops, people, farm systems, environmental footprints, while others will be demonstrating a particular farm system or a group of farm practices. And others again will be using controlled farmlet studies to impose treatments or answer very specific questions. Now, there's information on all of these projects on the DairyNZ website, and I really encourage you to jump on the website and have a look at what's happening in your region, or what's happening in a region that may have a similar climate or a similar landscape to you where you farm. So what I'm going to do is I'm just going to touch on 3 of the regions and the research that is occurring in those 3. So if you just jump to the, thank you, Sarah. We're going to start at the top of the country in Northland. And up in Northland, just out of Dargaville, we have what's called NAF, the Northland Agricultural Research Farm. Now, this is owned by Northland dairy farmers, and it was set up in order to conduct some robust research into issues that were relevant to them. So, you know, what were they being challenged with that they wanted to look at NAF? So previously they've focused on reducing reliance on imported feed and ran farm system comparison trials looking at the impact of a pasture-only system compared with a system that purchased supplements, compared with a system that grew crops up in Northland. More recently, they've looked at dairying in a variable climate and tried to answer the question is how can Northland farmers farm with these increasingly dry summers and some of the new restrictions that were coming in, such as the, you know, the FEI from Fonterra. And then on the 1st of June this year, we're going to embark on a 4-year farm systems trial, which is investigating future farm systems, which for Northland farmers involves some alternative pasture species and also a low input or low impact farm system. Now, in addition, overlying these sort of bigger projects, NAF's also involved in investigating the occurrence of heat stress up in Northland and also the impact of some of the regenerative agriculture practices. So if we move south a little bit down to Taranaki, what we've got down in Taranaki is 4 Dairy Trust Taranaki research farms. Now, these have been set up in order to try and create knowledge and develop solutions that help secure the future viability of dairy farming in Taranaki. And the key challenges that, you know, Taranaki farmers said that they were faced with was the summer dry in the coastal districts. So one of the Dairy Trust Taranaki farms has looked at what is the impact of spring versus autumn calving on that Taranaki coast. They've also looked at how can they reduce their environmental footprint, looking at different farm systems to try and reduce their greenhouse gas emissions and end leaching, and also investigating some of the technology that's out there at the moment, such as the spiky technology. More recently, they've looked at how they can create more value from their young calves. And what Dairy Trust Taranaki has done is they have, over their 1,200 cows, they've used a new breeding protocol, which has incorporated sex semen, short gestation bulls, beef breeds. And what they're doing, we've got a master's student working on this, is they're trying to identify and quantify what are the risks of this redesigned mating program. So right from the mating process through to calving, calf rearing, and right through into what's the, you know, potential market access. So if we carry on down south, Sarah, down to the bottom of the island, obviously last but not least, we've got the Southern Dairy Hub, or SDH, which is located just outside of Invercargill. Now, at SDH, there's a farm systems trial that's been conducted down there where they have got 2 crops, so fodder beet and kale, and they've got 2 levels of nitrogen fertiliser that's going into these systems, so what's called a standard and a low level. And they're using this farm system as a platform in order to try and answer some of the issues that were identified by the Southland farmers in 2017. So a key one of these was fodder beet, and you know, farmers wanted to know what were the cumulative effects of feeding fodder beet to cows. So right from in utero, when the dam's grazing fodder beet, through to these animals in their 3rd or 4th lactation. They've looked at wintering and what's the impact of crop type and soil condition on cow lying behaviour. You know, does it impact on this? They've measured in leaching in the farm systems with the different inputs to try and determine, you know, how best can Southland farmers achieve their end loss reduction targets. And currently SDH are investing in off-paddock infrastructure, and they will determine what the impact of this is within a Southland farming system. So I've just scratched the surface of some of these projects here, and there's some great work that's being done in all the regions. And I think what's been common across all of these projects is that they're all farmer-led. So we make sure that we have farmers involved in establishing the project, so determining what are the questions that need to be answered, what are the issues that need to be addressed within those regions, and then continue to work alongside them. And this is, you know, really important to ensure that these projects generate knowledge and produce, or, you know, develop solutions that are relevant to that region, that they're practical, and that they're adoptable by farmers in the region. And that's what we, you know, need to carry on doing if we want to get this regional resilience that we talk about.
Excellent. Thanks, Jane. We'll come back to you with more questions in the panel discussion, but let's head to some more regional research, the plantain at scale in the Tararuas, and Adam Duker. So Adam, what's happening with plantain?
Thank you, Sarah. So Albert Einstein, he famously said, "The more I learn, the more I realise how much I don't know." And I think with Tararua and this plantain project, it was a very fitting description, this quote, for the position about 3 years ago. We just finished the back of a 7-year DairyNZ research program called Forages for Reduced Nitrogen Leaching, and they identified plantain as a leading mitigation option in terms of a forage-based solution. So at that time, Tararua was they came to DairyNZ looking for a solution because they were operating low-intensive dairy systems, and they had, on the basis of high rainfall and leaky soils, they had an issue to address. So this project was born, and so what I'll cover today is 3 aspects of the project. I'll cover the production environmental value, go into some detail of plantain value from a farmer perspective, and then hone in on one area that this working group within the Tararua project has been addressing with palatability. So jumping into plantain, what is plantain? So always pays to start at the start, Sarah. Plantain, so it's a herb, and it's got a fibrous root system. So our monitoring has shown that it's got quite favourable summer-autumn growth in comparison to the traditional ryegrass clover species. And also it shows quite comparable or compatible production ability in that it adds some diversity to the sward, so that was discussed earlier, and it also allows quite close compatibility of grazing systems, in that the grazing rotation is similar to ryegrass clover swards. So our project is got a monitoring program looking at the productive value, and we've found that it's on par in terms of production value compared to ryegrass clover, and a good fit for pasture-based systems. So in Tararua, it's a good result in terms of we can introduce plantain, maintain the productive value, but this project is all about the environmental value of plantain. So we've got a specific need to reduce nitrogen leaching, and that photo on the right shows how plantain works to reduce nitrogen leaching. So each of those vials has a different percentage of plantain. So the more plantain within the diet, the more dilution of nitrogen within the urine from a cow. So that's sort of how it works. And the good news is plantain's now available in Overseer. So in terms of research result, it's a great result, and it allows farmers now the ability to demonstrate and have a measurable mitigation in terms of reducing nitrogen for their farm. So jump to the next one, Sarah. This project, though, it's all about adopting a new mitigation option. So I just want to stress that plantain's not for everyone. So this project has a specific objective to reduce nitrogen leaching, and individually farmers need to make that decision if plantain's the right fit for their system and what they're trying to achieve in terms of plantain adoption on their farm. It's one mitigation, and this project is about adding a new mitigation option to a farmer's toolbox. So this is from a Tararua farmer's perspective, and I think it really does describe the current state of play. Our objective for the project is to increase the favourability of plantain, so it's tipping that scales into the balance in terms of in favour of plantain. I feel it is currently in the balance with a lot of farmers, so they're sort of making this decision. And as a working group within this project, we're working with Tararua farmers and our research scientists to overcome some of those barriers you see in red. So that's the management complexity of introducing plantain to the system, weed control options, plantain persistence within the sward, and I'll focus now on the palatability challenges. So just one of those areas that we've been working through with our project working group. So in terms of palatability, we refer to it within the project as the green skeleton, and you can see visually in the paddock when ryegrass starts to deteriorate quality. In contrast, plantain visually still looks very green, but some of those older leaves are quite likely to be building up with high chloride. They've got low energy and high fibre build-up. So we've had quite a few reports from farmers saying, you know, cows go into the paddock and they come out, they graze the ryegrass and clover, but leave the plantain behind. So this is one specific area within the working group that we've done a lot of work with. What they've discovered is that the milkers generally leave some behind, and it's that older leaf that needs to be cleaned up. So basically strip those older leaves away, reset the plant, and it'll be good again in terms of quality and palatability. So I think specifically for going into spring, I guess as farming, if you've got plantain within the swarm and cows aren't touching the plantain, just consider yourself that there might be green skeleton plantain plants within there, and you need to reset that plant. So I've just quickly touched on a few aspects of the project. Finally, this project is all about farmers working with our research scientists to adopt a new mitigation option. It's all about accelerating that new adoption and getting a mitigation option available at scale, in this case plantain. We're 2 years into this project, and our focus is within the working group, overcoming those barriers of integration of plantain at a farm level. So for us, the more you know came from that research base, 7 years of research putting plantain as a leading mitigation option. And the more you need to know is being worked through with local Tararua farmers in partnership with research scientists from DairyNZ and also from our research partners that are listed at the bottom of the slide. So working in a co-development space and overcoming barriers to adoption. That's what this project's all about. Thank you.
All right, so that brings us to this discussion. If Ina wants to join us and Jane come back. So let's go back to 15-20 minutes ago when we were talking about bobby calves. So Henny has a question here. Oh, actually, that one got answered. Let's just
sorry, I did answer a few questions. So
oh yes, yeah, that's all right. Beef prices are already under pressure. What makes you think we could make it more profitable for growers?
Yeah, and I did answer that one as well, and it is that is a really major question. And that is why we are thinking of looking at new markets and new products. So do market research in places where we haven't been before, and testing the development of new products. So I mentioned already rosé veal is something that we have not done from New Zealand point of view. That's one of the ideas.
Then we've got a plantain question. So this was either to Jane or Adam, you can field this. So Henny has a plantain paddock and reckons it produces about 1 to 2 tons less than the conventional pasture they would have on the farm. So for a 100-hectare farm, that's 100 to 200 tons less of dry matter. How have other farmers responded to that? Have they had a similar experience? Any thoughts?
So in response to that question, we've got monitoring over 60, I think pretty sure 63 paddocks, and we've done the analysis, and on average it's comparable productivity, having ryegrass in the sward for our monitor paddocks to ryegrass clover. What we're finding is that there's increased growth through that autumn period, and that's a critical period for nitrogen leaching, to manage nitrogen leaching when plantain's in the sward. But on average, it averages out, and ryegrass really does come into its own through the spring. So yeah, we're keen to know if this is the issue, but that's what our monitoring is picking up.
Okay. Ina, you've also worked with Plantain a bit. Did you see anything different in other parts of the country for the production potential?
Yeah, I was just thinking about that too, because indeed, in general, plantain produces more in summer and autumn. So I'm not sure where this reduced or depression in production is coming from. I don't know which region, but even in plot trials, we saw even higher production from plantain in Canterbury than from ryegrass.
Okay.
So
that
we just think that on average it should not lead to depressed production, but
okay.
Of course, individual situations will be different.
Yes. Are you aware of any regional projects that are looking at wintering barns? That's a question for anybody that can answer it.
I cannot. I haven't. Oh, I'm talking out to Sarah. Sorry, I've lost my buttons. There has previously been some work looking at off-paddock infrastructure, so looking at loose house barn, freestall barns, right from looking at the investment in these facilities through to what is the technical requirements within all these facilities and how to manage them. So currently SDH is looking at some off-paddock infrastructure, so that will be exactly what it will be, is being decided on at the moment, but it will be whether it's a barn or a type of covered feeding area. That's what they're looking at investing, or that's what they're looking at investigating down in Southland now.
Okay, cool. Other questions? Anything else? I saw some people had raised their hands. Now we typically just take questions in the chat, but oh, and I realized it's 8:02 as well, guys. Okay, wow, I could just keep going all night. So I'm going to have to leave it there. Thank you so much for everyone that joined us tonight. Thanks to our presenters from around the country. We have both the North and the South Island represented, as well as Australia and the Netherlands with our presenters. So just to let you know, the webinar again is available online, and any questions we didn't get to, as well as all the questions Q&A, you can find on the Farmers Forum webpage. And if you've registered, you'll get sent a link to tonight's webinar. So thanks so much for your time. Have a good evening and good night.